14.5 Chain Rule Part 2. Here's a problem where z is a function of x and y. We don't know what it is. In the last video, it was specified like x squared plus 2y squared. We don't know what it is. We know x is 2u, y is u plus v, so x and y are functions of u and v. And we're given that partial of z with respect to u is 1, partial of z with respect to v is 0. And we want to find partial of z with respect to x and partial of z with respect to y. And such is the case sometimes in physical science. We don't know explicit relationships, but we do know rate of change relationships. A lot of the basic science statements in physics are rate of change relationships. And maybe we can get a handle on that. And we want to, knowing these two rate of change relationships, we want to figure out these two. So the first thing we want to do is write out partial derivative formulas. That's a good general rule in applied math. One of the problems students have is they look at a problem, they try to solve it all at once. Well, you can't do that when it's a difficult problem. So the best approach with this and any other applied math problem is write out what you know. Start writing formulas out, filling things in, and then that gets you halfway into the problem, and sometimes you can see your way out. Well, first of all, a chain rule formula is at hand. Z is a function of x and y. X is a function of u. You can put a v here, but there's really no v here. And y is a function of u and v. And so we want to write out the chain rule formulas. Partial of z with respect to u equals z sub x, x sub u, plus, now we can also get to that, partial of z with respect to y, partial of y with respect to u. And then let's write out a second formula, partial of z with respect to v. Now there's no v here. You can pretend there's a v if you want. I'll fill in the formula just for completeness. Partial of z with respect to x, partial of x with respect to v, plus partial of z with respect to y, partial of y with respect to v. Okay, that we can do. When you have a functional relationship, you can always write the formulas out using a tree diagram. Now we're going to fill in what we know. Partial of z with respect to u, we're given that that's 1. Partial of z with respect to x, okay, that's an unknown. Let's just call that z sub x for simplicity's sake. Partial of x with respect to u, that's 2. Plus partial of z with respect to y, that's an unknown. I'll write z sub y. And partial of y with respect to u looks like that is a 1. That's one equation, two unknowns. Now let's look at what we have over here. Partial of z with respect to v, we're told that that's 0. Partial of z with respect to x, that's an unknown. Partial of x with respect to v, okay, that's 0. Remember I told you you could add this term in, but it's going to zero out anyway, so I could have left it out. And partial of z with respect to y, that is an unknown. Partial of y with respect to v looks like that's a 1. There's our other equation. Now we have two equations, two unknowns. That's a simple linear system, something you learn how to solve in 8th grade. We can go ahead and solve it. Easy peasy over here. Okay. Z y equals 0. But if it didn't work out so easy, you could use some elimination method. So you can substitute over here, 1 equals zx times 2 plus 0 times 1, zx equals 1/2. So we have, there is our solution. We're able to figure it out. So there's some good applied math. Write what equations you know, start filling things in, and then eventually the solution's pretty easy. This obviously wasn't evident. Up here is just a whole bunch of symbols. Obviously you can't see your way to the solution unless you're like me and you've taught this course 72 times. So, okay, that's it for this video.